All right, in the last section for this chapter, we're going to be talking about writing the equation of parallel and perpendicular lines. You will need Desmos open for this. As a quick reminder, parallel means two lines with the same slope. And just as a reminder, if you have two lines, they will kind of look like this. They go like railroad tracks, never touch, never cross. Perpendicular means two lines with opposite reciprocal slopes. And perpendicular lines make a 90-degree angle, so they might look something like this, where they meet at a perfect 90-degree angle. Now, by opposite, we mean opposite sign. And that might be helpful to write down in your notes, so positive and negative, right? If the original is positive, the perpendicular slope will be negative, and vice versa. Reciprocal means upside down, as in literally turn the fraction upside down. Instead of 2 over 3, it would be 3 over 2. So the strategy is this, and let me scroll down so I can get all the steps on one page. Step 1, figure out the slope of the original line by counting. And remember that slope on Desmos is rise over run. So you're going to count how far up and how far over you need to go. So this is a Desmos. This is why you need Desmos so much. As a reminder, it might help to zoom in or out to find coordinate points. Sometimes if you're really far zoomed out, you can't see where it crosses exactly. And if you zoom in, those will be easier to see. Step 2, write the start of your equation using either the parallel or the perpendicular slope. So that's going to be y equals something x, whatever your original slope is. If it's parallel, you're going to use that. If it's perpendicular, you're going to change the side and flip it upside down. Step 3, you'll always have a coordinate point that your line needs to go through. So you're going to have this in Desmos and that in Desmos. And then step 4 is just guess and check. These kinds of problems aren't really difficult, but they take some time. If your line needs to go up to go through the point, so that might be where you have your line going like this, and the dot that it needs to go through is there. It's above it. You are going to add something. So try adding 5 or adding 15 or something like that. If your line needs to move down to go through the coordinate point, so that might be something like this. You have your line, and here is the dot underneath it. You're going to subtract something. And again, this is guess and check, right? You are only knowing if you have to add or subtract and then fine tune it to get it to go through the dot. So make sure you've got Desmos pulled up and let's start in on this. So the first example says, what is the equation of the line that passes through the point -3, 3 and is perpendicular to the line 3x plus y equals 9? So here's what I'm going to do. I'm going to move this over so that I can type on Desmos on this side. I'm going to start with this equation right here. 3x plus y equals 9. Now you can see here that I have my coordinate points. They're both at whole numbers, which is kind of nice because I can just count rise and run that way. If I did not have pretty whole numbers, I might be able to zoom in a little bit and see that there is a good coordinate point. There is a good coordinate point. The places where it crosses over perfectly are good places to choose. Something like this would not be a good point because it doesn't cross at a vertical line and a horizontal line. So I'm actually going to use this one here to here because that's much shorter. So I can see that my slope right now goes 1, 2, 3 down. So that would be -3 over 1. So my original slope is -3 over 1. Now I can leave it like that, or I can say that it's -3, same difference. So I noticed that it says perpendicular. Now perpendicular, if you'll remember in geometry, is labeled like that, kind of like an upside down T. So my perpendicular slope is the opposite reciprocal. So if you can see, this one is negative, so my perpendicular slope will be positive. And instead of 3 over 1, I'm going to have 1 over 3. So this is how I start. I'm actually going to go ahead and get rid of that line. I can start my equation as y equals 1 over 3x, right? There is my perpendicular slope. It's always y equals that x. And I'm going to zoom back out a little bit. I notice that it has to go through negative 3, 3. So I'm going to plot that point, negative 3 comma 3. And I need to decide, this blue line, is it above the green dot or is it below the green dot? It's below the green dot right now, so I need this to move up so that it goes through there. And so I know it's adding something. And then it's a lot of guess and check. I'm going to try adding 5. You'll notice that that's a little bit too much because it doesn't perfectly go through, but it's pretty close. If I try 4, that does go through exactly. So the equation of my line is 1/3 x plus 4. And it really is that simple. Let me exit everything out of here. The second one says, what is the equation of the line that passes through the point 6, negative 1 and is perpendicular to the line x equals 3y plus 3? Same idea. I'm going to start by finding out what the original slope is. And that comes from Desmos. X equals 3y plus 3. I've got some dots right off the bat here. They're pretty close to each other. I can also use this dot, or this dot, or this dot. Or even if I zoomed in a little bit, I could use this dot and this dot, or anything like that. Any of them work. I'm going to use these two. I'm going to rise 1 and go over 3. So my original slope is 1/3. Now, I need the perpendicular slope. So perpendicular slope. Now, remember, perpendicular means opposite reciprocal. This one right here is positive. So my perpendicular will be negative. And instead of 1 over 3, the reciprocal will be 3 over 1. You can leave it saying 3 over 1, or you can say that that's just negative 3, your choice. So my equation will be y equals negative 3 over 1. I got to say, I am not a fan of reducing fractions. Feels like a good place to make mistakes, so I just leave them alone. Y equals negative 3 over 1x. Y equals negative 3 over 1x. And then I notice that it has to go through the point 6, negative 1. So if I type that in. Now, this one's a little bit hard to tell, but it's definitely above the line. And it's above the line by kind of a lot, right? Like it is all the way this much. So I'm going to start by adding pretty big numbers. I'm going to start by adding 10. And you'll notice that wasn't even enough because my line, it's still above the line. I still need to add something. So I'm going to jump up. 15 is close. Now, because I'm old, I've got to zoom in. It's not actually on the line yet. Make sure you do play around with the zoom, because if you zoom out enough, it looks like it's going through the line, but when you look closely at it, not quite. It's still above the line. But I'm getting much closer, so I'm actually going to kind of fine tune. 16, not quite. 17 is spot on. And if you zoom in a little bit more, it doesn't change, still on the line. So this equation turned out to be negative 3 over 1x plus 17. All right, last one. What is the equation of the line that is parallel to the line 4y plus x equals 20 and passes through the point negative 4, 5? So same way, whether it says parallel or perpendicular, the process is the same. I'm going to figure out what is my original slope. So I notice that it says 4y plus x equals 20, so I'm going to type that in. 4y plus x equals 20. I see one dot, but I don't see another one that Desmos gave me, so I'm going to look for a crossing point. Here is a crossing point. here is a crossing point, here is a crossing point. Or if I wanted to zoom in a little bit, that's a little bit easier to see that here it crosses at a nice T-junction. Here it also crosses. So I'm going to use these two. So this looks like down 1, which is -1, over 4. So my original slope is going to be -1 for down 1 over 4. Now, this time I don't want the perpendicular slope because this question does not say perpendicular. It says the parallel slope. And those two lines like that look like parallel lines, that just means parallel. Now, if you'll remember, parallel means same slope. So if the original slope is -1/4, the parallel slope will also be -1/4. So I can start on my equation. The equation for this guy is going to start off y equals -1/4 x. It's always whatever you decided your slope was. Go back to the regular zoom. Y equals -1/4 x. Now, the point that it has to go through is -4, 5. And again, I notice it's above the line, right? The dot is above the line, so I'm going to need to add something. I'm going to try adding 5. That was a little too much because now my dot is underneath the line. So 5 was a little bit too much. I'm going to try 3. Little too low. My dot is above the line now. So 4 seems to do it about perfect. Zooming in just to check that it stayed on the line, and we are good. So y equals -1/4 x plus 4.